Let's talk about color. As I mentioned before, our cones see three different colors, and we think of them as red, green, and blue, which is why televisions are built around red, green, and blue. All right, so if you look at a television screen or LCD, you have red, green, and blue pixels because the red, green, and blue pixels are designed to excite the different cones in our eyes. And those um, those cones, red, green, blue, um, are how we see color, right? We get a signal on this one, and you see it doesn't peak really in the red, but it's the primary one we use for seeing red. And this one doesn't, it peaks kind of yellow green, and it's the ratio between all of these that tells us what color we're seeing, right? Blue cones are less sensitive, and look at how much distance there is between blue and red and green, right? There's not nearly as much overlap here. There's actually some a recent question is seeing blue relatively new? And the reason this question comes up is if we look at some of the ancient literature, there's a word for green, there's a word for red, there's a word for yellow, there are words for these colors, but there's no word for blue. The sky is always talked about as gray. The sea is always talked about as wine dark. So, it may be that they couldn't see blue, right? It may be that blue is relatively new. One other thing about color before we get into color perception and light sources and things like that. If you are a turkey hunter and you've always wondered why it's so hard to escape the notice of a turkey, that's because turkeys see way down here in the ultraviolet or in the shorter wavelengths. And so while you think you might be hiding from a turkey, um, their blue cones let them see you in much greater detail than a human would see you. And so your camouflage isn't basically. So turkey's much harder to hide from. Another interesting thing at Oak Ridge National Labs during World War II, there was a project where people were having to put these little bitty tiny wires through little bitty holes, and there was one woman that was way faster at it than everybody else, and um, she didn't even have to use a magnifying glass. And so when they started trying to figure out why is this woman so much better at that, what they discovered was she was red colorblind. Basically, she didn't have these cones. She just had blue and green. Well, the wavelengths that you see red at are longer, and you don't see as much detail in red as you do in blue, where these wavelengths are around 400 nanometers, these are around 700 nanometers. So the red, seeing red, or not seeing red in her case, allowed her to see finer detail than the people that could see red. And so they went through and they took out the white lights in all the rooms where people were working, and they put in blue lights, and suddenly everyone could work without magnifying glasses. Everyone could work faster. Um, and so this is understanding how we see, and we see finer detail with blue than we do with red, and all of that was very important in all of that. All right, that's it on our rods and on our cones. You've got notes over here about rods. Um, and we will talk a little bit about color production, like print and things like that, and lighting in the next video.